Hey,
Hmm?
don't you have to film that video for physics?
Yeah?
Yeah, the one about Newton's 3 laws.
Yeah?
Doesn't this scene kind of resemble the first law? Body at rest will stay at rest. Outside force. You know what I'm talking about, right?
Huh?
Hey, Apple!
Alright, time to head downstairs.
I'm heading downstairs. Hey class, first law. Anybody at rest will stay at rest, and anybody in motion will stay in motion, unless acted upon by an outside, unbalanced force. Let's see this in action. Right now we have our friend Bob here, who is at rest. He's chilling out. Some would even say maxing, relaxing all cool. There is no force acting on him, so he does not move. It is once there is a force put onto him, like a push or a pull, that he starts to move. But then why does he stop? Friction. Friction is the resistance caused by the interaction of two objects. Think of the surfaces of Bob's head and the rug. Fibers of the rug will push against the head so that it will stop moving. All surfaces are not perfect. There are inconsistencies, and with these inconsistencies comes friction. Like rubbing sandpaper against itself. The surfaces are rough, making it hard for the force applied to be able to continue. If you think about Newton's first law in very basic terms, it can be defined like this. Things chillin' will stay chillin', and things moving will stay moving, except if something stops it from moving. I think my sweatshirt matches this carpet. What do you think, Bob? Second scene, second law. The equation for the second law is net force equals mass times acceleration. This can also be rewritten for gravity, where the force of gravity is equal to the mass times acceleration of gravity, which is a constant of 9.8 meters per second squared. The unit for force is a newton, the unit for mass is kilogram, and the unit for acceleration is meters per second squared. Using this equation, we can find that 1 newton is equal to the amount of force required to move 1 kilogram with an acceleration of 1 meter per second squared. Okay, it might seem a little complicated, but think about it like this. You go to consume a hamburger. Pretty easy, right? The burger itself does not have much mass, and your hand accelerates it relatively slowly because you're not Joey Chestnut. Let's say the burger is 0.8 kilograms, and you accelerate it at 0.1 meters per second squared. You are therefore exerting 0.03 newtons of force on the hamburger, pushing it towards your mouth. Using these equations, we find that things that have more mass require more force to move. Here's something to think about. What would be harder to push? A hippo or a Zippo? A hippo would be insanely heavy. The other is just a little lighter.
Nice.
In conclusion, heavy stuff be hard to push. Light stuff be easy to push. And the easiness of pushing is measured in newtons.
Screw gravity.
Newton's third law. Every action has an equal and opposite reaction. You exert forces on the objects you interact with. Leaning into a wall provokes it and will make it angry at you. The wall will fight you as much as possible, resisting you from going through it. What does it look like? A door? The wall grew up and got bullied for being a door. How could you say something like that? The wall doesn't actually get angry at you, but it does react to your force with its own. The forces of your interaction with your environment is equal to the interactions of the environment with you. If this were not the case, the Earth could randomly apply a force to you and make you go flying. But this is not the case, because forces are equal against each other. If forces were unbalanced across the world, you could have situations like this. Whoa! 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 Where you couldn't control your own stool. Let's say I ride my cool racer scooter down the street, because that's a cool thing to do. I am applying a force down against the surface of the Earth, and thus it does the same against me. The reason I move is not because the Earth applies a greater force to me, but it has a much greater mass than I do, and thus I am easier to move than it. Think about it simply. Doing a thing will cause another thing to happen. It could be invisible.